So in this video, we're going to just do some more U subs. Some of these will be new techniques, potentially a new variation of how to look at a U substitution that you haven't seen before, and others will be good old practice. So I would highly recommend pause the video, try the problem, see if you can figure it out, see if you can think of something, and then unpause the video and see how it goes along. Um, Now, this first problem, I want to remind you, now that we know U substitution and we know some more advanced techniques, we always like to try those first. No, start with the easy techniques first, right? See if you can algebraically simplify. See if you can do something just to make it easy power rules or some kind of basic antiderivative. Now, what you're going to notice here is we're going to say, okay, let's do a quick rewrite. So the square root is the same thing as power of 1/2. And we're going to say, okay, I would love to distribute, but I can't. That power of 1/2 keeps us from being able to distribute. So maybe what we'll do is we'll choose a U sub. I'll do it over here to the side. I'm going to say U is equal to, now U sub is the chain rule, so I'm going to pick the inside of my function. And I'm going to get du is equal to 2 dx. Okay, so as far as the substitution technique, I have the dx. That's a perfect fit. What am I missing is the 2. So I'm going to use inside outside. I'm going to multiply by 2 on the inside. I'm going to multiply by 1/2 on the outside. And now I'm going to take a look and see what my problem looks like. Okay, so I have the 1/2 on the outside. I have this x left over. And then this whole piece right here, the 2x minus 1, that's my u. So I'm going to go ahead and fill that in. So I have u to the 1/2. Now, this is kind of nice because I could technically multiply these now because there's no adding or subtracting inside where that u is, but the variables don't match. So that's a problem. Okay, now this is your first time seeing this. How are we going to fix this issue? I need to somehow change this x into u. Well, we have a formula up here that literally does that. This is a formula that changes, x's into u's. So what I'm going to do is I'm going to solve for x. Okay, I'm just going to solve for x. I'm going to take this equation and say, okay, well, I'll kind of rewrite it, just give myself a little bit of neatness here. U equals 2x minus 1. I'm going to solve for x. I'm going to add 1 to both sides. So it's u plus 1 equals 2x. And now divide by 2. So that's going to leave us with x equals u plus 1 divided by 2. So now I have a new substitution equation. Everywhere I have an x, I can replace it with u plus 1 divided by 2. Pretty cool, pretty nifty. Okay, so this is going to be 1/2 times u plus 1 divided by 2 times u to the 1/2. I'm just going to go ahead and write it without those parentheses. Technically, you could look something like that. But the big idea here is now all my, don't forget the du. Don't forget the du. Danger, 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 right? That dx substitution turned into a du. Okay, so now we've got our du, we've got everything there. And so we're going to say, okay, my variables match. Now let's clean this up a little bit. I have a constant multiplier of a 2 in the denominator, so I'm going to go ahead and not do that. I'm going to go ahead and move that to the outside. So this is going to become 1/4 because it was in the denominator. U plus 1 times u to the 1/2 du. And now, because this doesn't have a power, there's no power there, I can go ahead, see I'm trying to be like there we go. I can go ahead and distribute. So that's going to be u times u to the 1/2. My exponents add, giving me u to the 3/2 plus u to the 1/2 du. And see, there's that simple algebra, that doing that little bit of algebra makes the problem so much easier. So now I can actually do the antiderivative. The antiderivative of u to 3/2, we're going to add 1, so that's u to the 5/2 divided by 5/2 plus u to the, we add 1 again, so that's 3/2 divided by 3/2. And don't forget your plus c, and we're done, right? No, don't forget, we didn't start with u, so we can't end with u. We originally knew that u, here we go, u is equal to 2x minus 1. So we have to go back over here and say, okay, so this is 1/4 times 2. I already forgot what I just said it was, 2x minus 1. 2x minus 1 raised to the 5 halves divided by 5 plus 2 times 2x minus 1 raised to the 5 halves divided by 3 plus c. There we go. So neat little use of u substitution, right? So to remember, we can use the substitution of 2x minus 1 and replace that with a u, but we could also solve for x and use that as our substitution to get rid of the x's and turn it into u's. Okay, so good new technique, pretty awesome, I hope. All right, let's move on to the next one. So now looking at this problem here, we see a similar format, right? We had this one, we had a square root. We're like, we can't distribute in because I've got a binomial underneath. So is this the same thing? Well, it's a squared. So if I really, really wanted to, I could just distribute this through. I could just distribute this as, x cubed plus 8 times x cubed plus 8, and I won't have to deal with any of that. And then, of course, multiply by x squared after that. But that would be like an old technique. That would be algebra, and that seems like it's going to be a little bit of work. Wouldn't be too bad, but it would be a little bit of work. So I'm also going to say maybe a nice u substitution. Look for a quick little chain and say, does that look like it would be less work, right? So we have two options. I could brute force and go algebra on it, or let's see if this works out for me. If I let u be x cubed plus 8, then du is equal to 3x squared dx. This looks like it might be a little bit less work, a little more elegant, right? So the x squared dx, that's a match. So what am I missing? I'm missing a 3. So I put a 3 in and a 1/3 out, okay? And so what is that going to leave me with here? Okay, everything I highlighted in green, that's a substitution for du. So we're actually going to write that. There we go. There's our du. And then the x cubed plus 8, that is a substitution for u. So that's just going to leave me with u squared. Now, where do most students make their mistake? They forget about the bounds, right? You either need to write x equals 4 and x equals -2. So we don't confuse our reader and accidentally sub that in to u. We have to say, no, you got to switch back to x first. Or what I prefer to do, and for those of you going on to Calculus 2, what we would highly recommend you do is convert your bounds, right? We're going to convert x equals -2. And because we have a formula right here that does that. So I'm going to say that's u equals -2 cubed plus 8. So therefore, u is equal to, well, -2 cubed, that would be -8 plus 8, which makes u equaling 0. Okay, nice. So that bound, that lower bound that used to be -2, became 0. We also need to convert the upper bound of 4. So we just take our function here and sub that in. Let's see, 4 cubed, I believe, is 64. 64 plus 8 would make 72. So therefore, this would be an upper bound of 72. And now notice, no x equals, it's just 72 because it's u. It's matching the variables we're working with. So now I'm able to anti-derive. So this is 1/3 times u to the 3rd over 3, evaluated from 0 to 72. And we'll go ahead and substitute that in. So that'd be 1/3 times 72 cubed over 3 minus 0. And make sure you do that little mental check, right? It's so often we just say, oh, it's 0, I don't need to write it. But sometimes 0 isn't 0. Like if it was cosine of 0, that's 1, right? So make sure you actually sub it into the function. Make sure it actually gives you 0. All right, so then this, I don't know. What I do know is 1/3 times 1/3 is 1/9. So I'm going to leave it as 72 cubed over 9. And of course, you could bring that up in a calculator. That's just not head math. And that would end up being 41,472. Enjoy. Okay, so there's our answer for that one. All right, so what is the big takeaway? Compare and contrast problem 1 to problem 2, right? They look somewhat similar. They both have a chain rule, right? And they both were done using u substitution. The difference was this first one didn't have that perfect match. It didn't have the it had the x on the outside, where my du didn't have an x to kind of substitute in, or to use as the substitution. Where this one had an x cubed on the inside and an x squared on the outside, so that du matched up. All right, so we're going to keep an eye on that. We're going to keep an eye on that, right? They look similar, but they are kind of two different techniques. All right, on to this one. This looks nothing like the other one. Oh my goodness, what should we do? Well, we've got options. Once again, I'm going to show you this problem two ways. I'm going to show you the brute force way, and then I'm going to show you the other. So what a lot of students do at this point is they say, okay, well, I'm just going to rewrite it. You wouldn't have to do this. I'm just going to go ahead and say, remember, this is cosine x squared. So we see the chain rule. We see u is equal to cosine x. We're like, that's probably a pick that we could try. And we're going to say, so that's du. So therefore, the derivative of cosine is negative sine x dx. And we say, hey, that's pretty nice, sine x dx. The only thing I'm missing is the negative sign, right? I need a negative, so I put a negative in, negative out, inside, outside. Boom. That's exciting, right? We love it when they work out so nice. So that's going to end up being 1 over u squared du. Fantastic. So just a tiny bit of algebra. Let's just rewrite this as u to the negative 2 du. We do our antiderivative. So this is going to end up being, we add 1. So this is u to the negative 1 divided by negative 1, which is really the same thing as multiplying by negative 1. So therefore, the negatives are just going to end up simplifying, leaving me with 1 over u plus c. And if we go find, because I forgot, there we go, u is cosine. So we're just going to pop over here, back here, and we're going to say this is the same thing as 1 over cosine x plus c. And that should trigger in our brain. We're like, we don't write trig in the denominator. We're going to go ahead and rewrite that using its reciprocal trig. So 1 over cosine is the same thing as secant x plus c. Now, if we stop and think about this, we're like, the derivative of this should bring us back to what we started with, because antiderivatives literally are derivatives backwards. So if I do the derivative of this, I should get back. So the derivative of secant is secant x tangent x, isn't it? So I'm going to go ahead and blow this whole problem up. You don't feel like you have to erase this. It's good practice as a u substitution, but this is a perfect example of we have a whole new technique that works. But if I were to just stop for a second and say, hey, I could have given you this problem before you learned u substitution, and you would have had to look at it like this. You'd have to look and say, well, this is the same thing as sine over cosine times 1 over cosine, right? Because it's cosine squared, the denominator. And then we'd say, okay, well, sine over cosine is the same thing as tangent, and 1 over cosine is the same thing as secant. So with just a little bit of rewrite, we turn this into a basic antiderivative. The antiderivative of secant tangent is simply secant. And that makes sense. That makes sense because way down here, right, we were like, hey, our answer was secant. So long story short, don't forget your old techniques. They still work. Okay. All right. So on to number 4. All right. Ooh, this is looking familiar. All right. So you may want to pause it. You might want to try to take a run at it and see if you can recognize the technique. Okay. Welcome back. For those of you who paused the video, for those of you who didn't, that's a weird time lapse. You're like, wait a second. Anyway. Okay. So we recognize this. We have that square root with stuff underneath it. That's a chain rule. So we're going to say that looks like it would be 1 plus x squared. So therefore, du would be 2x dx. So therefore, we have the dx, and I need 1x right here. Do you see we have 5 of them? So just if you don't have to write it like this, but I'm going to write it like this just to make it easier to see for those of you, since I'm not in a classroom with you, to really make sure you're seeing what I'm trying to, say. So notice x to the 5th is the same thing as x times x to the 4th. So for this substitution, I need 1x times dx. So I take one of them, kind of peel it off, and write it separately. So therefore, now I can say that x I highlighted and the dx are going to be part of my u substitution. That's going to take the out. We're going to take that out and put a du in. So the only thing I'm missing now, is the 2. So I'm going to put a 2 in and a 1/2 out, inside-outside technique. And there's my substitution. So everything I just highlighted in yellow is gone, and that's going to become du. Now, the thing that I have underneath the radical, that becomes u. So this is looking similar to problem number 1 as far as our conundrum. If we have a mixture of x's and u's. So we either say, this doesn't work, let me try something else, or we go back to this original equation, we say where u is equal to 1 plus x squared, and we solve for x. Now, for those of you who see it, there is a quick way of doing it. For those of you who don't see it, you'll still get it right. Our first step is saying u minus 1 is equal to x squared. If you see x to the 4th, and you say, well, I could rewrite that as x squared squared. Well, then for my substitution, now I'm just going to say this is 1/2 times u minus 1 squared u to the 1/2 du, right? And because everywhere I have an x squared, I can replace it with u minus 1. Now, there's some of you out there who are saying like, yep, nope, wouldn't have seen that. Okay, so I'm going to go ahead and do it the other way. We'll get to the same answer. It'll just take an extra step or two. So for those of you who said, no, I just would have solved for x. Okay, fair. So that's u minus 1. So we're going to do the square root of both sides. So that's plus or minus. So it's going to be plus or minus the square root of u minus 1 is equal to x. Okay. So we'll go ahead now and we'll sub that in. So what would that result in? That would give us 1/2 times the antiderivative of, I'm going to write the square root as 1/2 power. So I'm going to make that u minus 1 to the 1/2. And then that whole thing is raised to the 4th. Oh, and don't forget the plus or minus. Silly me. Plus or minus. There we go. Of u to the 1/2 du. All right. Now, a little bit of algebra kicks in. We're like, first of all, the plus or minus on the inside here, because it's raised to a 4th power, a positive times a positive times a positive times a positive is a positive, and a negative times a negative times a negative times a negative is a positive. So it turns out they don't really matter because we have an even power. So what we're really just looking at is something like, u minus 1 to the 1/2 raised to the 4th u to the 1/2 du. Okay, fantastic. That was exciting, and I'm running out of space. Okay, then we say, what do we do when we have powers raised to powers? Powers raised to powers multiply. So 4 times 1/2, or half of 4, makes u minus 1 squared times u to the 1/2. And look at that. That puts us right back to what we did the other way if we just recognize the x squared substitution. Cool. Now, the original problem, I would not have been able to substitute. Not substitute. That's not the word I'm looking for. I would not have been able to distribute because I had a power of 1/2. And unfortunately, I don't know how to multiply 1 plus x squared to the 1/2. I don't know how to FOIL it, distribute it. I'm kind of stuck. But down here, notice what happened. The thing under the radical that used to be, the thing under the square root that used to be a binomial is now a monomial. It's just u to the 1/2. And the other part that used to be a monomial is now a binomial. But the difference here is that power is squared. I know how to multiply through things that are squared, right? I know that. So that's just going to end up being, and just as a side note, if for those of you who may not know what I'm saying, I'm just distributing through u minus 1 times u minus 1, right? So I'm going to do u times u and then u minus 1. I'm just going to distribute through. So that's going to give me u squared minus 2u plus 1 times u squared du. Okay? And now, and if you need to do step by step, you can feel free to pause the video, do that on your own. Then what I'm going to do is I'm going to be able, now I can distribute this through. That step of multiplying u minus 1 times u minus 1 got rid of the power. And now I can distribute that little bit of algebra that was tripping us up. So now u squared times u squared is u to the 4th minus 2u to the 1st times u squared would be u to the 3rd plus u squared du. And I apologize, that u looks really, really ugly. Let's fix that, plus u squared du. Okay, so now, this is the magic moment. You're like, yay, or maybe not, but whatever, you're something, because now we can actually integrate. So this is u to the 5th divided by 5. minus 2u to the fourth divided by 4 plus u cubed divided by 3 plus c. And that's magic because we're done. Now, just remember we didn't start with u, so we can't end with u. U was originally 1 plus x squared. So we're going to be left with 1/2 times 1 plus x squared raised to the 5th over 5 minus 2 times 1 plus x squared raised to the 4th divided by 4 plus 1 plus x squared cubed over 3 plus c. And you can leave it like that, or of course you could distribute the 1/2 through, and that would just make this 10, 8, and not that, 6. There we go, plus c. Oh, and then of course now we have the 2 and the 8, so we could divide those, making it 1/4. Anything else to clean up? No, I think that's about it. Okay. All right. So we're making fast work of these problems. These problems can't stop us. We're calculus rock stars. All right, moving on. Number five. Holy cow, this doesn't look like anything of the other problems. Okay, I don't have a chain rule to work with. This isn't a basic antiderivative. I cannot write this as 5x to the negative 1 minus 1 to the negative 1 because that's not how math works, right? So I'm kind of stuck. I could write it as something like 5x to the minus 1 or minus 1 to the negative 1 dx, but that doesn't help me. I mean my u would be 5x minus 1 maybe, right? So therefore du would be what, 5 dx? Okay. So therefore my substitution would be 5 dx. So I need to put a 5 in and a 1/5 out. All right. So what is that going to turn us into now? We're going to be left with 1/5 u to the negative 1 du. Oh, cool. And if you recognize it, you're done. If you don't recognize it, I would just say you could always try to power rule it. Right? Say, okay, that would be u to the 0 divided by 0. Wait. That doesn't make any sense. So let's just write it back. So it's 1 over u du. And hopefully now you're like, yes, now I see it. That is my natural log. So therefore, this is 1/5 times the natural log of u plus c. That is it, and that is the most common mistake. You're going to get a red X and more, and you're going to want to throw your shoe at the computer screen. You'll be like, why? Don't forget the absolute values. Okay, now that we have that, we're going to say, okay, again, we didn't start with u. So that would be 5x minus 1. So we're going to go ahead and just plop back in there. 5x minus 1 plus c. And you'll notice, right, the idea is we maintained our domain. The original problem, I could substitute in any value I wanted for x other than what would make the denominator equal 0, which would be 5x minus 1 equals 0, so therefore 5x equals 1, so x equals 1/5. So I could sub in any number I want, positive, negative, just as long as it wasn't 1/5 that made my denominator 0. So now logs, right? Remember, logs have that same property. We wanted to maintain that same property, and the issue is logs are only defined in the positive values. So therefore, I wouldn't be able to substitute in anything that makes it negative. So what do? We just throw absolute values around it. Now it matches. All right. But I still can't do 0 because it has the vertical asymptote at 0. So it maintains my original domain. All right. One more. Now, you might recognize this and say, okay, I see it. This is the same thing, right? The chain rule is really, truthfully, if I were to rewrite this as 5x cubed minus 1 to the negative 1 times 2x squared dx, you're like, there's my chain, there's my inside, right? So hopefully you're starting to recognize, you're like, just pick the whole denominator when it looks like this. Because the whole denominator would be, what, 15x squared dx? And of course, don't mess around with the constants. Just look. That 2, we're pulling it out. I can take that 2 out of my original function because it's a constant multiplier. Can I take out the 5? Well, not easily because it's not the 5 isn't multiplying the whole denominator. It's only multiplying the x. I still have that negative 1 there. So if I wanted to be able to pull out the 5, I'd have to do something like this. I'd have to do 5 times x cubed minus 1/5. dx. I'd have to do something like that. And that just seems, I don't know, not fun. So I'm going to factor out the 2. I'm going to take that 2 out because it's already factored, but that 5 I'm not going to touch. So now for my for my u substitution, I'm looking for my match. I have an x squared dx. That's pretty nice. What is the thing I'm missing? 15. So I put a 15 in and a 1/15 out, inside, outside. And that, everything I highlighted in yellow is my du. 5x cubed minus 1, that's going to become u. So that's going to leave me with 2. Oh, scratch out doesn't work. 2/15 times the antiderivative. All the yellow stuff, notice I highlighted everything. All the yellow stuff becomes du. The numerator has nothing left in it. So many times funny things happen here. This u has to be in the denominator because the 5x cubed minus 1 was in the denominator. So what do I need to put up here? I need a placeholder. I need something to hold it. A lot of times you write the du, but I personally think antiderivatives are easier to see if we don't. So I just put a 1, right? Just something to show. There's, it divided, right? So it turned into 1. It's substituted. So what are we left with now? 1 over u. Hey, we just saw that. That looks familiar. The antiderivative of 1 over u is natural log. And you're like, I'm not going to get fooled again. It is the absolute value of 5x cubed minus 1 plus c. Boom. There it is. We are calculus rock stars. All right. There is 6 problems. 6 additional integral problems. Please go back and use these to help you kind of look for patterns, right? What are we looking for? Chain rule is always the inside. Are you is typically that part of the chain, the inside function from a chain. So we're going to try that. If we don't have a perfect match, right, we're going to go back and say, okay, well, I had an x left over. Let me use this function to solve for x, right? Or we had the other technique of it works, right? Don't get all distracted and try to start solving this u equation for x, right? Just let it be, right? The old technique works. And then the big moral of the story, don't forget your old techniques. They still work now that we know u substitution, okay? All right, hope that helps. Hope that's a good 30-minute recap of how to do these problems.